Hello everybody, we are going to start the second presentation of this second day of the International gvSIG conference. This presentation is given by Almostaba Hasabo, and this is about GIS for appropriate flood risk planning towards a sustainable economic development, the case study of Khartoum State in Sudan. So whenever you want, you can start.
Yes, hello everyone, and thank you for attending this presentation. Today, I'm going to show you how the open source geographic information system, gvSIG, can help policymakers create prevention and protection policy that aim to reduce the vulnerability of people, public and private property. Here's the title of my presentation, and I'm going to introduce myself. My name is Muhammad Hassan Hasabu. Actually, I'm from Sudan. I'm a GIS economic development planner, and I'm here today because I'm interested in the following area of project: GIS for livelihoods, GIS for business intelligence, GIS for economic development, and GIS for development planning, and GIS for risk management. You find my email at the bottom. So okay, climate change like high temperature, heavy rainfall, and seasonal variation result in flood occurrence that was in case in Sudan July 2020. Actually, more than 100 people died and more than 100,000 homes were destroyed. People has to take shelter in the home of family member, mosque, church, and school. As a result, the Sudanese government declared a state of emergency for the 3 months and announced Sudan as a natural disaster zone. Here, GIS is a powerful tool to draw map for potential flood risk area. Actually, some researcher, here is the name, apply GIS-based approach to conduct flood hazard mapping using different parameters like land use, land cover, soil, river network, and slope, and so on. Actually, I prepared this picture in desktop, but I don't know if it is visible or not visible. Actually, this is the picture. It shows the damage in the public and private property and losses of life in 2020 in Sudan. These figures shows the damage and losses in terms of houses affected, people, and public utility in each state in Sudan in October 2020. You can note here in the table that Khartoum has the highest losses compared to other states. The table here is show different states of Khartoum that damage or the damage of the different states in Khartoum that happened in 2020 flood. These are other states. We can see the damage in terms of people, houses, and other utility for every Sudan state. Actually, this slide is show the damage and affected people from the 2013 to 2019. And this slide is the damage in Khartoum only. So shows that the state of Khartoum has the highest losses on property and life. So if we want to understand the situation of flood in Khartoum and in the old Sudan, we have to study every element that play role in the flooding. In this Nile profile, as we can see, the Nile flow from south to north, and we can see also the Nile flow from south to north, and the White Nile and the Blue Nile, which meet in Khartoum State. Lake Tana is located in Ethiopia, and it is provide 25% of the water for the Nile River. Actually, this is a real picture for the Tana Lake in Ethiopia, and this is where the two Blue Nile and White Nile meet. This meet in Khartoum. The population of the country that live along the Nile basin for every country, like Egypt, Rwanda, Kenya, South of Sudan, and so on. Sudan population has large population in the Nile basin effect. Actually, it is 41 million that the total population of Sudan, 35 million that live in Nile basin. The next 9 slides shows the effect of weather condition on flooding in Khartoum. Climate change as a result of high temperature, precipitation, heavy rain, and seasonal variation, and this change are responsible for flood occurrence. I will discuss each condition one by one as a result of using GIS spatial analysis and special data from free portal, which called ESGF. This is comparison between temperature in 2005 and the protection of temperature in 2050. We can see here in this picture, comparison between two pictures, the increasing change in temperature. Also, the next map show, or this map show, the change in temperature in area of Sudan from 2005 to projected temperature in 2050. This time, this slide frame is applied for amount of precipitation as we can observe the projected change. Actually, the map show there is decrease in high average of precipitation in 2050. And this because of seasonal rainfall variation, as we will see in coming slide. This map shows the area affected by level of precipitation in Sudan between 2005 and 2050. The slide from 2020 to 23 compared change in relative humidity in the same as 6 months time period between the year 2005 and 2050. As we can see, there is increase in relative humidity for each month. In 2020, the Blue Nile recorded the highest water level since the year 1988, during which heavy flooding occurred in Sudan. The next two slides shows the change in rainfall in Sudan from 2010 to 2019, from June, July to September. We can see the variation in the line chart, but we cannot say there is decrease or increase during this period. So what is the adopted solution? As Sudan is less developing country, here is the limited budget project cannot provide the cost of installing, maintaining the commercial software. Therefore, the open source geography information system, gvSIG, is the solution because it has had good database and fantastic spatial analysis, and it is also very friendly for user and easy to learn. This pilot project proposed the techniques of fluid systematically mapping using geographic information system, gvSIG, to digitalize factors such as elevations, as we will see in the next slide, slope, land use, distance from rivers, topographic, and so on. So the objective of this project is to map area in the state of Khartoum, Sudan, to flood risk zone, to create a model for developing an area warning system. And this warning system will share this information with policymakers using the geographic information system, gvSIG, as we will see in the next slide. In result of successful of this research or of this project, it can be used to identify flood hazard in other states and reduce the availability of people, public and private property for sustainable economic development. So how we are going to make this happen? Gathering information for this project from land use, from map of infrastructure, hydrology, and existing maps such as floodplain, base map, and flood map. This is the data collection. So this map shows the level of elevations in the state of Khartoum as the case study of this pilot project. The level of elevation is the factor that affect the possibility of flooding. Also, this is a map. All is done with gvSIG. This is a map of degree of contour in the state of Khartoum. Khartoum is located in the lower contour. South of Khartoum is located, as we can see, in the lower contour. And the majority of the population is located there. We will see this in next slide. Actually, this is the high place. It's done by gvSIG, which also affect in flood. When we come to flood history of Khartoum, this presentation will show, or this presentation is showing the pre-flood area of Khartoum in 2007. And this in 2007 also, but in August month. The next slide is in 2007 for the September. This in 2013 also in September. This in 2013 in the September, but for another days. Here is the increase of flood in 2013 for in the same months. Here in the 2014, as we can see, the flood in Sudan is in Khartoum in 2013, 2014. This is the increase in the same months, but different day. This also in 2014, 2014. This is in 2016. This is the history of flood in Khartoum State. So the outcome of this research. This slide shows the natural This slide shows the flood area in Khartoum and the level of the flow. In the red color, the flow here is high. In the yellow color is medium, and in the green color is low. This all is done by gvSIG. If we bring and integrated an analysis the above mentioned together using gvSIG and also the previous map of flood risk area in terms of high, medium, and low, we can find here that the settlement in Khartoum State, which are located in low risk area, medium risk area, and high risk area in the red color. And here also is the name of what? Of administration inside Khartoum by its different located. The map is not clear, but this is the population density. As we can see, the most of population is located or live in the area of high risk, here in the blue. Actually, this is the global probability, like railway. Most of the railway is located in the red color area, which means is the most of railway is in risk zone in Khartoum State. This is the vegetation of and the natural that in Khartoum State. Different color shows the area in hectare. We can see that is the big area. This green color, dark green color, shows a big area. It is located in the medium, and the light color, most of it is located in the high risk area. This the land cover, which is cover Khartoum State. Here also is the area, size of the area in hectare. We can see some of it is located in the high risk area in Khartoum State. The electricity also, the main electricity line, we can see here some part of electricity line located in the high risk area. There is no one in low risk area, but it is divided between low or medium risk area and high risk area. Here is the cultivated land in Khartoum. Most of it is located in the median risk area, and some part of it is located in the high risk area. Actually, that's what I wanted to say today, and thank you again for those who come, and I want to open the question, if any.
Okay, thank you very much.
Thank you.
If there is any question you can ask at the chat, or if you are going to watch the video later at the gvSIG YouTube channel, because it will be available from tomorrow, I think. You can ask at the video as a comment, or you can write Al-Mojtaba by email. So if you have any doubt later. So we are going to wait a few seconds if there is any question.
Yeah.
It's a very interesting project that can be applied in a lot of places, in a lot of countries. Do you plan to make another analysis similar to that or continue with the project?
Yes, I think also there is a new version that has, as I read in the yesterday in the email, that has good special analysis.
Yes.
So I will use this special analysis for the another project, using the different states, because now I talk only Khartoum is the case study of this project.
Okay, nice. So very interesting. So we are going to. There isn't any question at this moment. So as I told you, if you have any question, you can ask at the mailing lists. You have here the Almostaba email address. So if you have any doubt, you can ask him directly. So we are going to finish this presentation now, and we invite you to follow the next ones at the GVSIG International GVSIG conference. So thank you very much, Almostaba. Thank you very much, everybody.
Thank you,
and
Mario.
see you at the next presentations. Bye bye.
Thank you, Mario. Bye bye. Thank you very much.